and after both the sessions we have USRP.
Yes.
So hardware demos and hardware codings, hardware programming, so we'll see on Saturday. Logics in LabVIEW communication design suite. And how you can use it for your learning purposes also. Is it fine, ma'am? And after. So I'm just sharing my.
Yes, sir. Sure, sir. Sure.
So since Saturday we have hardware for complete day, we'll use hardware on complete Saturday.
Yes, sir. Sure, sir.
So this is LabVIEW next generation. So almost 16 members are there. I think we'll start. Very good afternoon to all. We'll go with LabVIEW communication design suite. How this is, or else no problem. I'll just start with the basic programming. How you can start with basic codes. How you can do your logics. How you can work on it. So see here they have given a lot of templates. If I want to work on any LTE with this, or if I need to have some learning things. So here, signal processing, signal conditionings, how I can do them, or any mathematical codes, how we can include in it. Things, or you can go on FPGAs, how you can include FPGAs in your codings. So how you can write a single channel code or multiple channel codes. And here hardware, if you are using a hardware, how you can use your hardware to it. So here if you see NI modulation toolkit for software defined radios, so you can use for your coding techniques, encoding and decoding techniques you can use with this. And different oscilloscopes, how you can write a program for modulation toolkits, how you can do modulation schemes, how you can go for your continuous transmission, FSK, PSK, how you can go with that. So those things you can define here in it. So these are all your examples programs where you can learn and work how you can use this for your regular classworks also. So this is one way you can use this for your uh, teaching purpose. Very lightly you can use. If you use LabVIEW, you can completely use with all of your algorithms you can develop there. So here it's something as lessons based, projects based, where you can get start directly. The templates are available, you can start and move. So for example, if you say hardware, this will tell you about hardware coding. So for example, you can choose any DAC cards and you can write program and you can deploy in it. So here we are not going to work on any hardwares. So today we are going to. So here it is showing only about my computer and the USB camera associated with it. So now, for example, if I want to make my own project, for example,
Sir, excuse me, sir.
yes, ma'am.
Sir, it seems Saujanya ma'am is saying in chat box that your screen is not clear and your voice is also breaking. Seems.
Come again, ma'am. Come again.
Actually, Saujanya ma'am is saying in chat box that your screen is not clear and your voice is also breaking sometimes.
Is the screen clear? My page black color window is there, right? Could you all can see it?
Yes, sir.
Okay, 1
But
minute.
it seems not clear.
No, voice is clear now.
Now okay, sir. But previously it was something breaking, sir. Your voice was breaking, and now also the image, the screen you're sharing is blur.
Okay, I'll just stop it and I'll share it again.
Okay, sir.
Is it clear? Now you could see the black color screen. You see the template is background is black color.
Okay, okay, sir. Okay. Now it's okay. Okay, sir.
So it's fine right now.
Yes, sir. Yes, sir. It's okay, sir. It's clear.
It's clear, right? Okay, fine.
Yes.
So due to some network issues, it would be. So no problem.
Okay. Thank you,
Sorry.
sir.
So we
Okay.
just go for a new project. I'll just create a new VA. So whatever we are planning to do with this, so I'll just create a new VA. So if you see in it, if you are trying to work with the hardware, here you have those options. So if you're working with an analog input module, but the thermocouple module or a pressure module or a strain module, or you're going to generate any signal out of it, or you are going to measure a counter input pulses, or you're going to have a digital controls. So it depends upon the modules, you can choose here your application. Now I'm going to work with the basic LabVIEW programming or for the communication purposes, so we can use it. So I'll just show you how things you can make with it. So I'll create a new VA. So now in this, I want to make it out how exactly I'm going to define my front panel and block diagram. So now if you see there, the left side, I have all the navigation plans. So I have a plot where I can define my front panel. And here, if you see there, I have a block diagram where I will define all my logics and codings here. So panel is to show what are my input and output here, user interface. Diagram is to show me what are the logics I do here. So if you see in the panel, here I have this numeric control. So I have a different types of numeric controls and indicators I have. So this is for Boolean. So this is for text, and this is for array types, and here it's for clusters. So this is for pictures. Similarly, if I go for block diagram, here I have for loops, for loop, while loop, case structures, and if I go for different data types, I have numeric, Boolean. So here I have addition, subtraction, functions. I have a lot of functions. So here I can define what type of operations I'm going to perform. So this is for comparisons, exponential, trigonometric, or matrix, or probability. So you can do all your mathematical applications here in that. So this is for signal processing. So here you can generate a signal, you can filter a signal, you can condition them, you can analyze them. So you can define your modulation schemes, AM modulation or FM, you can define them. So here you can go for what are all the options you can get with, you can easily do. Uh, Excuse me, give me a moment. Hello, ma'am. Ma'am, 1 minute. Let me stop sharing and get back to you. Give me 2 minutes.
Okay, sir. Okay, sir.
Okay, yeah, 1 minute. Hello,
Sir?
ma'am. Is it clear, ma'am? Now
Yes, sir. Clear, sir.
screen and voice is clear, right?
Yes, sir.
Okay. Okay. Sorry for the disturbance here. I got a call here. Sorry.
Okay. Thank you, sir.
So here, if you see in diagrams, we have different options for our algorithms defining here. So I'll just show you how exactly we can define our own GUI, how we can plan for things, we can do it. So for example, if you see, I'll go for numeric. So I'll take a numeric control. So I drop them. So I'll just select drag and drop. So whatever we'll make with it, numeric control. So I have a numeric indicator. So I have a knob control. So then I take something as a I take something as a meter. So here you can expand the size of the meter. So here you can define what is your range of it. So for example, I'll give 1000. So the values will automatically vary there. So here I'll say 100 pressure gauge. So I'll just type. So I'll say pressure. So this is voltmeter. Now it should not be 100. So I'll say 300 volt RMS. So here, what are all the values that you can modify it? You can change here. So this is your numeric purpose. So now if I go for a boolean, so here I have a boolean button. So I have a button here. So here I can say on or off. The same I have a stop button. So if I'm defining something for a power on, so I have a checkbox. So whether it is on or off. So it's all boolean, whether it is true or false. So here I have a round LED. So whether it is on or off will be defined here. So here these colors also we can vary it. So whether it should be in what color, so we can modify them. So for example, now I have got this blue color here, right, on or off. So when I go for properties here, so which color I want to change. So on it should be green. So in false state, it should be black or it should be red. So now once I define it, that's it, over. So now I can modify them whatever things I need here. So this is on off. I can define them. So similarly, if you see here, I have a string control. So I can type my name here. So for example, if I want to choose something as a list or a path or something, so what I can do is I can take something as a file path. So now if you see here, I'll browse for some file. So I'll say here, so I'll say 5G. So now if you see here, this is the file path. So what do I have in it? So I defined it. So file path. So from here you can access it. So similarly, you can use it for a graph. Hmm. Graphs and chart. So we can have a different types of graphs we can have. So for different signals, so you can take a different graph. So here you can define a polar graph. So you can define, so how exactly you want to make your things, you can use it. So now if you see these many elements I have taken in my front panel. So now what are all the things that we have added in it? So it's all available here. So for example, if I'm working on a numeric applications, I can only select the numeric options. I can work here. If I'm working on something as a knob, gauge, or a meters, I can only choose it. So whatever I required, I can take that. Rest of things, it can remains there only. So now if you see for number 2 here, I connected to numeric, and knob I connected to the pressure gauge. I'll take this boolean button. I connected to the round LED there. So boolean to boolean, it connects. Do you see the different colors represents different data type? So for number it is orange color. For pink it is for green it is boolean. So there will be a pink color. for string. So we have different options. So now I go to the panel. So this is to run my code. So I'll say run. So what happens is now the code is running. So here if I say 5, so this will run once. So this 5 will come there. So now I connected this knob. So this high to 1000. So if I change to 100, if I vary this knob value here, so now I run this knob value to 50, so pressure gauge value also to 50. So I am not modifying this pressure gauge value. So based on these knob values, this pressure gauge value also will vary. So do you see here, these changes, whatever I'm making, I'm defining my on-off options here. So if I say button LED will be green here. So this is what I have given the connections there. This button value should update in round LED. This knob take 3. So now I have these 3 elements. Do you see there are on the top, there are some attention symbols are there. So when I click that, do you see these items are unwired? So you need to wire them in order to process it. So how do you do that? So since I have taken numeric options, I have to work on numbers. So here I have a data type. So I'll go data type, numeric. So here I have addition, subtraction, multiply. I have options there. So I take multiply. I don't want to do a plus b. So I'll just take multiply. So now I take this icon. Do you see this icon has an error? So I cannot run my program. So there is an error here. So do you see this icon is throwing an error? So when I double click this icon, it will tell me this error belongs to here. This error belongs to here. This error belongs to here. So it will tell me where exactly you have this error. So I take a wire, I connect here. So this needs 2 input. I connect over here. So now I go to my front panel. So now I run. I don't know what happens there because it multiplying. Whether it adds or divide or things, I don't know here because all the values are 0 here. So now I just select them. I hope it is visible to you all. So I'll say 10. So here I'll say 3. So now when I run it, so I got the value 30 here. So if I say it as 5, I run it again, so it will update here. So these are the changes what we are making here. So this is to run your code once. So if I want to run my code continuous, so what I supposed to do, I want to enclose this in a loop. So here I have a loop, I have a while loop. So I'll enclose it in a while loop. So this while loop needs a condition when to stop. So I create a control to it. So I add a time delay. I add a time delay so that it runs at a very faster rate. So I create a constant. I'll say 100 millisecond time delay. Now I go to front panel. See, I don't have any stop button because that stop button is here. So whatever is unused elements will be there on the tray. If I want, I can drag and drop here. So this is my execution here. So now what I'll do it is, so I run my program. So now the code is running there. So do you see on the top it is saying it's running. So when I do any changes here, it immediately affects over there. So now I'll say 1.25 as 0.36. So this is going to give me the output of the respective decimal values there. So here the decimal values I mentioned. So I say stop. The code stopped. Now I say it as 100. I'll say it as a 5. Output will not change because I'm not executing my program. I just modify the input unless until I run, the things will not happen here. So I stop it. So this is to stop my code. So now if you see, this is the basic simple thing. Similarly, I can generate some signal, I can acquire them there. So I go here, I'll create one more VA. So now what I do it is I need to have a graph. So I take a waveform graph. So I keep here. So now I need to have a control for knob as I'll say frequency. So now I'll say this is 100 hertz. frequency. I'll make it bigger. So this graph also I make it bigger. So now I need one control for amplitude. So now what I'll do is I just made my front panel here. So I need to go for a stop button so that when I use some while loop to run continuous, so I'll make use of the stop button. So now I go to my block diagram. Okay. So now what do I need is I need to go for a signal generation. So I'll go for a signal generation. I need a signal processing generation. I have a waveform generator here. So whether I need to generate a sine or sawtooth, I can define them.